I got demands from some AI learners to explain the most important concept called gradient descent, which runs AI systems in the world. So I will explain this concept intuitively and with clarity in my video. Ever wondered how machine learning models actually learn? Like, how do they magically adjust themselves and get better after every epoch? Well, it is not magic, it is mathematics. And in this video, I will make you feel that math using just one simple diagram. Hey everyone, I'm Akash Gupta, and here I simplify complex AI and ML concepts so you can actually see what is happening behind the code. So today we are going to talk about the core learning engine behind every machine learning model. That is called gradient descent, the method your model uses to reach minimum loss step by step. Alright, so let us look at this diagram. So here on the x-axis, we have parameter theta. This is what the model tries to adjust like weights in a neural network. And on the y-axis, we have the loss, which tells us how bad our model's predictions are. Before we even talk about gradient descent, let us understand this curve itself. So this green curve is our loss function. It measures how wrong the model is for a given theta. If the loss is high, the model is doing poorly, and if the loss is low, the model is performing well. Now, why does it look like this nice smooth U-shaped curve? Because most common loss functions like mean squared error or cross entropy increase as you move away from the correct parameters and decrease as you move towards them. In regression, for example, if your predictions move further from the actual values, the squared error increases on both sides, creating this symmetric bowl-like shape. This is called a convex function, which means there is only one minimum point, that is global minimum, and that is why simple machine learning models love convex losses. They are predictable and easy to optimize. Alright, now that we know where this shape comes from, let us see how the model actually finds the bottom of this bowl. The goal is simple. We want to reach this point C. Now, look at two other points. So this point C is just the target or minimum loss point. Then we have two more points called point A and point B. And we have these balls rolling over the curve. And now let us reach step C. So suppose my function, loss function, starts at any random point A, suppose. Okay, now I want to reach point C. Now here there are two orange lines. These are called tangent to the function, and at point A, these line shows that the slope of the function or del L by del theta is less than 0, which is negative. And at point B, the slope of the function, that is del L by del theta again, that is more than 0. Now, suppose if I am at point A randomly, suppose, now I want to reach point C. Okay, so now here at point A, we know that the slope is negative, right? Now, since the slope is negative, and to reach point C, we need to increase the theta. That is the way. So I know that whenever at any point the slope is negative on the function, then I need to increase my theta at any point here. If the slope at all these points slopes are negative on the left side, so at these points, if I am at these points, then I need to increase my theta to reach point C. So that is what I want if slope is negative. Similarly, if I am at point B or at any point on the right side, and here I know that my slope is positive. So I know one thing, that if my slope is positive, then to reach point C, I need to decrease my theta. Okay, fine. So I got one conclusion, that if I am on the left side of the curve, then I need to increase the theta just to reach point C. Similarly, if I am on the right side of the curve, then I need to decrease the theta to again reach the point C. Fine. Now look at this update rule. That is the heart of this concept. It says, so I am starting at any random value of theta. Now it says that theta I plus 1 equals to theta I. So basically I am trying to find the I plus 1th theta, means the next value of theta. So gradient descent is just an iterative optimization method where I keep updating the values of theta starting from the random value. So if I want to get the next theta, so I suppose I am at A, here it is theta, we can say I. Okay, now I want to go to the next step in order to reach point C. So I want to reach here, suppose. Okay, that's my journey and I want to reach here. So at this point, my theta will be theta I plus 1, suppose. Okay, so theta I plus 1 will be what? That is theta I, this value at point A, value of parameter, minus, this is called eta. So this is called eta, which is learning rate. We will talk about the eta later. Minus eta into del L by del theta, that is the slope. So now see how this formula is working. So In this formula, you can see that if del L by del theta is negative, then I will add something to theta I, because when del L by del theta is negative, so my formula will become theta I plus 1 is equal to theta I negative eta, and then again negative sign with slope. So negative and negative will become positive, and I will add something to theta. So it is automatically adding something to theta, and it is basically bringing me closer to point C. Similarly, suppose if I am at point B, here, if I want to update theta, I know at point B slope is positive. So theta I plus 1 is equal to theta I minus eta. Eta is always positive. That is called learning rate. So eta into del L by del theta, which is positive. So basically, I am subtracting something from theta I. That's what we want to reach point C. If I am at point B, I will decrease my theta to reach point C, and theta is getting decreased automatically here in this formula. So since slope is positive, I will subtract something from theta I, and if slope is negative, this formula will add something to theta I, and then I will be closer to point C. So that is the magic this formula has. Now let us talk about this eta, the learning rate, which decides how big each step is. If eta is too large, then we might overshoot the minimum and keep bouncing around. If it is too small, then we will take forever to reach the bottom. So eta decides that how big my every step should be. So the learning rate eta is like your walking speed downhill. Steady and controlled gets you there fastest. So here is what really happens during the training. The model starts somewhere at any random point, say point A. It calculates the slope at that point, adjusts theta accordingly, then takes a small step downhill, then again slope, adjust and step over and over until it settles near point C, where the loss is minimum. So that is literally how your model learns. Each iteration is one small adjustment towards making better predictions. This same process runs behind everything, from linear regression to deep neural networks. So next time someone asks you how a machine learning works or how a machine learns, you can literally draw this curve and explain. Because at its core, AI is not about fancy architectures. It is about this humble idea. Follow the slope step by step until mistakes are minimum. If you like this simple visual explanation, subscribe Concepts of AI. I will keep turning complex AI ideas into visuals you can actually understand.